Okay, the next rule is the power rule. So this is an expansion of the product rule because it's really repeated multiplication, which is what makes it an exponent. So when we have a base with an exponent raised to another exponent, what's going to happen between those two exponents is going to be multiplication. So if I have x to the a to the b, this is going to be x to the a times b, or you could just write it x to the ab. We know that means multiplication. So for example, if I have something like x to the fourth power to the third power, that set of 4 x's is happening 3 times, and so in the end I end up having 12 x's. So these end up being multiplied to give me x to the 12th power. Works the same way with numbers. I could have 3 to the second power to the third power, and I would multiply just the exponents to get 3 to the 6th power. Now if I have a bunch of things in the same parentheses, I've got to understand that that exponent is going to be distributed to everything. So for example, if I have 2 to the third power, x to the second power, y to the fourth power, and it's all inside of a parentheses being squared, I have to realize that this 2 is going to be multiplied by every exponent inside the parentheses. So this is really going to give me 2 to the 6th, x to the 4th, y to the 8th. Well, if they ask you to leave it in exponential form, that would be your final form of the answer. If they actually ask you to continue to simplify completely, the only thing you can simplify further would be the 2 to the 6th power, and we know that that is 64. So the most simplified version of the answer would be 64, x to the 4th, y to the 8th. A common mistake I see is that students will see things like 3x squared y cubed with a squared next to it, and they do distribute to the first 2 exponents here, but they forget to distribute it to that constant out front. We forget that there's an understood 1 exponent with this number out front, so this is really 3 squared x to the 4th, y to the 6th. So we're looking at 9x to the 4th, y to the 6th. So don't forget, whenever you see a variable or a number without an exponent, there's an understood 1. So our examples to fill out on the notes for these, we've got x squared to the 3rd. We multiply these two, so it gives us x to the 6th. The second example is actually mixing together the power rule and the product rule, so I need to take care of these parentheses first. I've got a -2, and keep in mind this negative's in parentheses, squared, and a m to the 5th squared. So this is going to be -2 to the second power, which actually comes out to be a +4. And then I've got m to the 5th to the second, which gives us m to the 10th. And that's times m to the 3rd. Well, there's an understood 1 here, so I'm going to do 4 times 1, which just gives me 4. And then since I'm multiplying m by m, I can use that product rule that tells me that I can add the exponents to get m to the 13th. So if there are just numbers out front, we got to remember to just multiply them like normal, add our exponents. If there's a coefficient out front of a number for the power rule, I've got to remember to distribute that outside exponent to that number as well.